Hi, my name is Björn Boltoft and I'm product manager for real application testing among other products in Enterprise Manager. This session is about real world testing best practices before and after a database upgrade. The agenda for today is to cover Database Migration Planner, SQL Performance Analyzer, Database Replay, and Workload Analysis. When upgrading or migrating your databases, there are lots of challenges. First of all, new hardware are very powerful. So it's not uncommon to have 50 or even more databases on a clustered platform. I'm planning to migrate or consolidate databases to a new platform. Then I need to understand if the server or cluster can handle my databases. Another question that's often arising is, how should I migrate my databases? So I need to decide a migration strategy, but migration to another platform with a large database and minimal downtime needs to be tested, and you have to know that there are no problem when performing the migration. So how can I do this with minimal efforts? We do not want to read through a set of logs to find out what may have gone wrong. One of the most important part of an upgrade or migration is to make sure that you have same or better performance on all SQL statements. So how can I identify regression, and if our new platform is more powerful, then how can we identify regression if it's shown improvements? Do we have any plan changes, and how do we detect that? It is not only plan changes that can cause issues. What is happening under high load? Any performance issues, or do we see contention anywhere? A desktop simulation is one thing, and it can provide helpful information, but it cannot be compared with testing with the production workload. So we have foreseen all issues and are now happy in our new production environment. So can we relax? It is not uncommon that there are something that change. So how do we detect the root cause of workload changes? A SQL statement just change execution plan? Is it better or worse? What was the old plan? Can we make sure that we revert back to the plan? A database is not always static. We need to gather new statistics. We may change access structure, or we change init parameters in the database. So how do we make sure that there are no regression after these changes? Real application testing is the solution for all these questions. Real application testing has a comprehensive toolbox with features for upgrading and migrations. If I'm consolidating one or several databases into a consolidated environment, will they fit? Database Migration Planner can help you with the answer. We use performance statistics from production and perform simulations to calculate capacity needed now and in the future. Database Migration Workbench is a wizard-driven tool for moving your databases. SQL Performance Analyzer, SPA, performs unit testing on unique SQL statements, identifies performance changes and plan changes on these SQL statements. Database Replay records production workload and replays it in a test environment so we can identify concurrency issues during load. Workload Analysis compares performance using collected SQL tuning sets captured from different time periods and provides a root cause analysis of changed performance, such as more executions in one or the other period, new execution plans, more data to access, or other changes. And then we have SPA Quick Check that helps you to identify the impact of a change. You will get the answer if performance improves or regress, generating new statistic, or when adding a new index. So let's see how this process can look like. This is the recommended order for the complete process. We start with analyzing the capacity, selecting databases, adding growth factors to make sure that the new platform can accommodate all databases. Next is to decide how to migrate the databases. Zero downtime, incremental cloning, and other factors should be considered. Now we know how to clone the databases, and we are now in a good position to test the migration strategy and make sure it works. Because SPA and Database Replay needs a clone of the production database where testing can be performed. So why not test migration as part of the test workflow? Next part is to capture workload so we can test it. We should capture SQL tuning sets to be used by SPA and a workload capture to be used by Database Replay. So while we capture these artifacts, we can also start the cloning of the database. We have a test database, and the first step is to use SQL Performance Analyzer to identify SQL regression. SPA is essential, and we have seen that in projects where SPA have been omitted, database replay can take 3 to 4 times longer, which delays the project. Another important part here is that SQL regression is the number one reason for problems after an upgrade. SPA is an iterative process, and combined with SQL Plan Baseline and other tuning advices, it is powerful to make sure that there are no or limited regression while running database replay. See it as the racing team will not put the car on the track if they know that year 4 and 3 doesn't work. They will fix it, and so should we do with the query regression as well. Database replay may reveal other issues, so if such are found, then we fix and tune, adding new patches if needed, and when we are satisfied, it is time to upgrade and migrate the database. We are now in production, so our goal is to monitor and make sure that there are no new issues. We may have tested the most common scenarios, but it is difficult to test all different workloads. There may be a monthly batch or similar that may not be tested. So how can we be agile and make sure that we identify and remedy any issues as soon as possible? A runaway query in a batch may cause it to take longer than expected. So this is where workload analyzers make the difference. We can now analyze and identify regression and restore performance as soon as possible by knowing what was changed and how it behaved before the upgrade. So let's take a look at the Migration Planner. As we said, first step is to use Migration Planner. The good thing here is that Migration Planner is a non-intrusive tool. We collect historical AWR statistics and other historical EM metrics for the database and its underlying host into the Migration Planner repository. This data can be used for performing different simulations based on a particular scenario. Will there be enough resources if migrating to an Exadata with 4 compute nodes and 8 storage nodes? How will it work if we estimate a growth of 20% a year? When will we be out of resources? We have a very deep knowledge of our own offerings, such as autonomous databases, Exadata, Exadata Cloud Solutions, and OCI compute nodes. But we can also perform simulations based on spec metrics for commodity platforms. On Exadata, we can perform good knowledge on storage, but on commodity platform, we can only provide resources needed. What will Migration Planner provide you with? First of all, we can provide you with total capacity needed. Do I need 1 server or compute node, or do I need 8? There will be information about capacity needed for each database, and there will be information on violations, such as database A cannot fit into the configuration at all. So that becomes a violation, and the database will be excluded from the calculation. We provide the information in either a heat map or a line chart graph, where colors indicate if there are resources available or if we are close to the limits. Both heat map and line charts is per hour, and the result can be based on conservative calculations, which is hourly peak, to the aggressive scenario, which is hourly average. The default graph will show the resources with the highest value for each hour, but it is also possible to drill down to a specific resource. So let's take a look at SQL Performance Analyzer. One of the most common issues when upgrading a database is that there are queries with changed execution plans. The reason is that the optimizer are constantly improved, and at least during major releases there are changes in the optimizer code. So why do we have regression if we improve the optimizer? Unfortunately, improvements may cause the optimizer to evaluate the improvements before one of the rules that a certain statement have used to get an optimal plan. And there is a limitation in how many plans that will be evaluated. So how should we make sure that this doesn't happen? Optimizer feature enable set to an older version will not work, since it will restrict the optimizer from using features newer than the setting. But plan evaluation will still use the optimizer for this version. So we need to test, and this is where SQL Performance Analyzer can help us to automate testing, providing simple read reports. From our experience, we have seen that if SPA is used before database replay is used, it will save lots of time. A few years back we have a situation where a 30-minute capture took 5 hours to replay due to regression in one SQL statement. When later used SQL performance analyzer, we identified the SQL statement with the regression in less than an hour. The fix was simple. In this case we used SQL Plan baselines, which was enabled by integrating from SPA. We can also use SQL Tuning Advisor to find a profile or other recommendations directly from SPA. The SPA workflow is rather simple. We capture one or several SQL tuning sets from production during different time periods representing different distinct workloads. The capture of SQL tuning set has a low impact on the database with minimal overhead. We test execute these statements using bind variables from production against the production clone before changing it. Then we implement changes and test execute same SQL statements. We generate a report that provides us with information on regression and improvements. As long as the regression is higher than the threshold, then it's considered as a candidate for tuning or creating a SQL Plan baseline. We can run this process as many times as we want, because SPA does not change content in the database. The SQL tuning set can be used to test different scenarios in a trial, such as what happens if I'm adding an index, what happens if I'm changing an init authora parameter, and as said before, SPA integrates with SQL Plan Baseline and SQL Tuning Advisor. This will make it possible to make sure that there are no queries with major regression when progressing to database replay. This is how a SPA report can look like. Here we have test executed a SQL tuning set after an upgrade. The global statistics shows that there is a regression, and we have a regression of 341%, but there are no improvements. Number 2, this is the number of statements with regression. By selecting this graph, we filter the lower tile to only include regress statements. The tile in the bottom provides detailed statistics on which statements that have changed and how much it impacts. The net impact on the workload is based on the amount of execution, so a statement with more executions will contribute more to the net impact of the workload. There is also a net impact on the SQL, and as we can see, the top query has a less net impact on the SQL compared to statement 3 to 6. The reason for this can be that query 1 is executed more frequently, or as in this example, the original execution took more time to begin with, so even if the increase per SQL is lower, then the total amount of buffer gets is much higher. Let's take a look at database replay. SQL statements are now tuned, and it's now time to progress to database replay. So what is database replay? It is a recorder of all user activity in the database. We intercept user processes, and they will write activity to capture file, where each capture file represents one user session. The capture and a clone of the capture database is moved to a test environment. In tests, we process the capture, which creates replay metadata, and then we can start the replay, which will run the capture workload against the test database. The replay can be executed as many times as needed, as long as we flash back the database to the starting point. We can either perform a baseline replay against the non-changed database, or we can progress directly to replay against the upgraded database. It is recommended to perform a baseline replay first, since we can't guarantee that we capture 100% of the workload. Something may be handled by DBMS scheduler, which is not captured, or it can be non-supported workloads as well. The more of the workload that is not captured, the more important it is to have a baseline replay. After the replay has finished, then we provide reports that will help you to identify errors that need to be fixed and eventual regression that needs to be tuned before next replay. When we have fixed regression, then we are in a good position to upgrade the production database with minimal risk of production disturbance. Things to consider when replaying the workload. The database server needs to be equal or better equipped than the production environment. If the database has lower specs and it becomes a bottleneck, then it will cause the replay to be slow. The replay is almost an exact execution of the production workload. So if there was 1,000 concurrent users during the capture, it means that there will be 1,000 concurrent users during the replay as well. So both CPU, memory and storage needs to match production. Replay clients are the driver of the workload and should be located on dedicated infrastructure to simulate the application tier. As long as the application tier is located on other servers than the database, then the replay client should be located on other servers as well. By co-allocating replay clients with the database, we introduce a second source using CPU, memory and I/O, which make it harder to identify who are using the resources. When replaying the workload, we have two different synchronization methods, time-based and SCN-based synchronization. In earlier version there was a third called object ID, but it was not reliable, so we have deprecated it. So which method should you use? The answer is it depends on. Our recommendation is to start with time, since it's the least complicated. If the replay works fine, then continue with this mode. By working fine, we talk about rather low divergency, less than 10%, and it should not cause high load on the database. It is also the only option that works if you stress test your database using think timescale and connect timescale, since the reduction of it will have minimal effect when replaying in SCN mode. If time-based doesn't work well, then test with SCN. There are certain workloads that are difficult to replay using time, such as application with a high number of select for update transactions, or applications with a high dependencies between transactions. SCN-based replays are very sensitive to untuned statements, so it's important to run SPA first, or the replay will, without any question, take longer time with lower concurrency. So how does the regression manifest during a replay? The difference is rather big. The nature of time-based replay is that there are no synchronization between different sessions. Every session is trying to do its activity according to the time schedule. So if something becomes slow, then that session needs to continue its activity until it's ready. This means that if the session becomes delayed, it needs to compete on resources with other sessions that enter the database on time. More sessions and more activity will eventually increase the congestion in the database and delaying even calls that had no regression. So the increased activity has an exponential weight graph. The longer we replay, the more weights and congestions. This is exactly what's happening with traffic congestion. Sooner or later there will be gridlocks as well. SCN-based replays will have different symptoms. Instead of increased workload, it will be reduced workload. Now all sessions have dependencies between each other, and activity from one session are not allowed to progress before a certain activity is committed. So if I have a regression, there will be a stop and go every time a session becomes delayed, and all other sessions needs to wait until finish. The last phase is to analyze the outcome. Always start to investigate the functional aspects first. How much of the workload was replayed usefully? Was anything excluded? How much divergence did we have? As long as divergence is rather low, we can accept it. So what is low divergence? We have seen that less than 20% is a fair replay and less than 10% is a good replay. There will always be something that doesn't work as expected. Isn't 20% rather much? If we compare to other testing tools, it is rather limited. First of all, how many tools provide a production-like replay covering 80% of the application? Or even 20% of the application is hard to cover. Not said that we should ignore the divergence. We should always investigate it. What type of divergence is it? Is it caused on certain objects or schemas in the database, background jobs or less important workflows? Can we investigate the root cause? A table was not populated caused by capture restrictions. Can this be handled by a manual workaround? We can only provide information based on the database itself, like new errors or data divergency, less or more rows, etc. We have no intelligence that identifies if there are any issues with a computation or similar. So we do recommend to do some analysis of application metrics. Do we have 500 orders in the system? Is the order total correct or similar? After the function analyze has passed, then we can progress to performance analysis. Here we have standard database reports such as replay, compare peer report, EWR reports, EWR compare peer reports, and ADDM reports. By starting to look at the database time, it is easier to drill down and see if there are any performance issue and where they are. Let's take a look at workload analysis. We are now in production and the upgrade went well. But testing all might be difficult. There might be monthly batches or even year ending in the system. So it is more or less impossible to record all different scenarios. Workload analysis can help us identify if there are regression on non-tested workflows. Workload analysis using SQL tuning sets and compare performance and execution plans for 2 different time periods. Here we can detect regression and root cause of the regression. It could be new SQL statements due to an application upgrade that results in increased workload. Another factor could be that we still have same execution plan, but we have increased workload. There are 2 ways to schedule an analysis task. One-time analysis. This is actively executed by the DBA, selecting the reference workload and selecting the compare workload. The schedule analysis is automated by the EM job scheduler. Here we can schedule a job that executes daily at a certain time, or monthly, such as certain day in the month or the last day in the month. The schedule analyses are always using baseline. This baseline can be a fixed baseline, such as we want to compare performance on month ending with month ending January and using it as a reference. But it can also be a rolling baseline, comparing month ending with previous month ending. Both of them has its own purpose. Fixed baseline is better to detect small changes over time, such as some queries regress less than 1% per month due to increased data volumes. But if you compare between January and December, there is more than 10% regression. The rolling baseline will help you to detect changes caused by plan changes. Previous month, a certain query used execution plan A, and now it's changed to execution plan B with a 10% regression. There is a new menu item in the Performance tab, Workload Analysis. When arriving to the home page, we have 2 tabs, one for Schedule Analysis and one for One-Time Analysis. There is a dashboard where we show information on the total number of analyses, analyses with regression, and also analyses with improvements. The default execution reports on 3 different metrics, and on the home page it is possible to expand each task to see different reports and get the ability to select a specific report for drill down. The report by itself provides information on overall performance, if it has improved or regressed, breakdowns on common SQL executed during both time periods, and if there are improvements or regression, and missing and new SQL statements. It's also possible to filter by selecting a certain category, and the bottom tile will then include only this category. The bottom tile includes detailed performance information for individual statements, and if there are statements where further investigation is needed, then it's possible to drill down to single statement. The detailed SQL report includes details on all metrics. You will have before and after value for elapsed time, CPU time, buffer gets, I/O, and a few others. It will also include information about findings. You can also compare execution plans. If it's a new SQL statement, it will only include the new execution plan, but if this is a common SQL statement, there is both before and after plan. The conclusion is that real application testing will help you to test any changes in the complete lifecycle of your database. For more information, go to oracle.com Enterprise Manager. We have a video series, youtube.com Oracle Enterprise MGR. We have blogs.oracle.com, documentation, and you can also try our hands-on lab, using the Oracle Cloud free tier. It's now open for question and answers.